Okay, exercise 4.2. This is an exercise where you have to determine whether two sentences or sometimes three are logically consistent. And again, this concept of consistency applies to sets of sentences. So it can be as little as two, as many as you want. All right. And when you are determining whether a set of sentences is logically consistent, the first step is the same as in 4.1. You do the truth table. All right, that's going to be consistent for all the exercises in chapter 4, most of them. Is first you do a truth table, then you test for whatever you're looking for. So in 4.1, we're looking for equivalence. So we had two sentences and we were comparing the columns under their main operators. Consistency, though, is different. To be consistent just means it's possible that they could all be true. All right, and to be inconsistent means it's impossible for them all to be true. Right? So if I said I'm richer than Bill Gates and Bill Gates is richer than Elon Musk, but I'm not richer than Elon Musk, that would be inconsistent, right? Because if I'm richer than Gates and Gates is richer than Musk, then I must, by logic, be richer than Musk. So inconsistency is something you want to avoid, right? You want it to be the case that all of your beliefs or all of your claims could turn out to be true. So we'll start with number 2. We're going to do some even numbered ones since the odd ones are assigned for homework. This is number 2 in exercise 4.2. Again, I'm using tables. And to do that, you just click on insert, and then go to the table, and then you can pick a table of whatever size you want. All right. So here we've got two atomic sentences, P and Q. So we've got a 4-line truth table, TTFF for P, TFTF for Q. The first sentence is just the conjunction of those two. And we know that a conjunction only comes out true if both conjuncts are true. So we don't even have to fill in the P's and Q's. And, as you go with truth tables, you get better at this. And the main thing is, and for the exam, what you're going to need to do is at least have the column under the main operators filled out. But if you need more than that, that's fine to do more than that. All right, over here we've got P or Q. And again, this is just the truth table for disjunction, which comes out true as long as at least one of the disjuncts is true, and only comes out false when both are false. Okay, so that's it. Truth table's done. All right. Now, if we were looking for equivalence, we could see these are not equivalent because they don't have the same truth values on two of the lines. But we're not looking for equivalence, we're looking for consistency. And again, to be consistent just means it's possible for them both to be true at the same time. So what we're looking for is any line on the truth table where both or all of the sentences come out true. And in this case, we find it on the very first line. All right. So because we found one line, and that's all it takes is one line, where both sentences have the value true, that's all we need to prove that those sentences are consistent. Okay. So with equivalence, you need these two columns to be exactly the same for them to be equivalent. For consistency, though, all that you need is to find one line where they have the value true. Okay. All right, number 4. Again, it's two atomic sentences, M and N. So we've got 4-line truth table, TTFF, TFTF. First column or first sentence is just the truth table for conditional, which we know is false on only one line, where the antecedent is true and the consequent is false. So that's our truth table for M conditional N. Now here's a case where, again, you might want to fill in more. So not M is just going to be the truth values flipped for M. So here TTFF, FFTT. Not N is going to flip the truth values for N. Okay, so now we do the conditional. So it's true, true, false, true. Okay, so that's the truth tables filled out. Again, these two sentences are obviously not logically equivalent because they have different truth values on the second line and the third line. But again, for consistency, all we need is one line where they both come out true. And again, we find that on the very first line. Right, so if M and N are both true, this conditional comes out true because you have true, true. This conditional comes out true because you have false, false. Right? So as soon as we find one line where they're both true, we know they're consistent. Now here there's multiple lines, but again, all you need is one line. So even if you have a 32-line truth table and 31 lines you don't find all true, but one line that you do, that's enough. Consistent just means it's possible they can all be true. And so if we find one line where they're all true, that means it's possible. Okay, problem number 6 is again two atomic sentences, X and Y. So we've got 4-line truth table. First sentence is just the conditional. So we can fill that in, T, F, T, T. And again, don't forget that when an antecedent of a conditional is false, the conditional comes out true. That's a mistake I'm seeing on some of the homeworks. Now here, the second sentence is reversed, right? So we could fill these in if it makes it easier, because otherwise it can get confusing. So Y is TF, whoops. TF, X is TF. And so now the truth table for these, we get T, F, T. Why are my centerings off all of a sudden? Now in this case we have 3 sentences, right? So not just 2. Remember, consistency applies to any number of sentences. 2, 3, 4, 5, whatever. All right, so now we've got not X here, so we'll fill that in. We get F, F, T, T. Not Y, we get F, T, F, T. And then we do the disjunction for those. Let's look at these. Okay, so remember disjunction, if they're both false, comes out false. Yeah, false, true, true, true. All right, so now this is the truth table filled out. And we need to now see if there are any lines in the truth table where all 3 of those sentences come out true. So the first line, we've got true, true, but we got a false here. Second line, the first sentence is false. Third line, true, false here. Fourth line, true, true, true. So the fourth line, they all come out true. So it looks like we want to say these are consistent. Now, if you ever have a case like that and you're kind of suspicious, like, wow, maybe I did that last line wrong, you can go back and plug in the values, because what this is telling us is that when X and Y are both false, all of these sentences come out true. So we can go back and plug in the values. So if we have false, conditional false, that does indeed come out true. Again, false, conditional false comes out true. And then here we'll have true, disjunction true, which comes out true. So indeed, when both X and Y are false, all 3 of these sentences do come out true. So they're consistent. Again, all we need is that one line to show consistency. All right, number 8 is a 3 atomic sentences, so that's why we've got 8 lines. First leftmost column, half true, half false, so 4 true, 4 false. Next column in, we alternate twice as much, so 2, 2, 2, and 2. Next column, alternate twice as much, And since it's our last one, it alternates every time. All right, first sentence is disjunction of S and U. You got to look at the first column and the third column here. So we got T, 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 F, T, and F, right? So these two lines, both S and U, are false. So they're the only two false here. Now, next one we've got conditional, S conditional R. So we look at the first two columns, the S and R, and if we find T antecedent F consequent, comes out false. We've got true, true, false, false, true, 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 true. So again, these are the only two lines where we have true antecedent, false consequent. True antecedent, false consequent. All right, last one is not U, not R. So I'll fill in the not U first. It's going to alternate every time, but it's going to start with F. So FT, 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 FT. Not R is going to be the flip of the R, so it's going to alternate twice, starting with false. F, F, T, T, F, F, T, T. All right. Now we'll do that conditional. Remember, conditional comes out true, except where you have TF. So true, false, true, 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 false, true, and true. Okay. So the truth table is done. Now again, we go look for a line where they all come out true. And again, it looks like the very first line gives us such a line. So we're going to say these are consistent. And if you're thinking we filled out that whole damn truth table for one line, you're right. And if you haven't gone ahead to exercise 4.4 yet, you'll see that in that section, there's a method called briefer truth tables, which will in fact allow us to skip writing out the whole truth table. And again, if you're suspicious that maybe that isn't the only line, there is at least one other line where they're all true. But again, you can take these values and plug them back in, right? Because this truth table is telling us if S, R, and U are all true, all three of these sentences should come out true. So again, if S and U are both true, this comes out true. If S conditional R, TT, that comes out true. And this one, you'll have false conditional false. So that'll come out true. So indeed, that first line is a line where all the sentences come out true. Means they're consistent. And the very last one, last even numbered one, number 10. Again, it's a 3 atomic sentences. So it's an 8-line truth table. First line half and half, starting with true. Next column, alternate twice as much. Next column, alternate twice as much. And again, remember your truth table should always have all T's at the top line, all F's at the bottom line. If you don't see that, something has gone wrong. All right, so first now we have a biconditional. Then we have a conjunction and a regular conditional. So let's fill in the U here. We've got T, 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 F, 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 V or W. Now we're going to look at these two columns. So we've got T, 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 F, T, 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 F. So it's a disjunction. Disjunctions only come out false when both are false, and that only happens twice. Now we can do the biconditional. Remember, a biconditional comes out true as long as they have the same value. So if they're both true, we get a true. If they're different, like this one's TF, that's false. And if they're both false, like in the last one, comes out true. So the biconditional comes out true if they're both true, or if they're both false, comes out false if they're different. If one's T and one's F. All right, U and not V. Again, T, 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 F, 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 F. Oops. So not V is going to be F, F, T, T, F, F, T, T. Right, so I just took the V column and flipped all the truth values to get not V. Now the conjunction, they both have to be true for the whole thing to be true. Now W conditional not U, so the W is just TF, TF. not U is going to be the flip of U. So it's going to be F, 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 T, 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 T. Conditional comes out false if you have true antecedent false consequent. Otherwise, it is true. Okay. So that's the truth table. Now, again, see if there's any lines where they all come out true. This one we have two falses. This one false. This one false. 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 And false. So this is the first time we've seen a sentence that is or a set of sentences that is inconsistent because there is no line on which they all come out as true. All right, so that's how you do that's how you use truth tables to determine if a set of sentences is consistent or inconsistent. Again, for extra credit, you can do some of the problems from Q2 in 4.2. And those ones you have to set up your own truth table. Remember that truth table gets set up according to how many atomic sentences there are. So if you have 2, it's going to be a 4-line truth table. If you have 1, it's going to be a 2-line truth table. If you have 3, it's going to be 8-line truth table. And I think even in Q2, there's a couple that have 4. Yeah, number 9 and 10 both have 4. So if you have 4 different atomic sentences, that's 2 to the 4th power. 2 times 2 times 2 times 2 is going to be a 16-line truth table.